Okay, we are on top of the hour. I see we have at least the first speaker here. We have our area director here, so I think we can start. We only have 60 minutes, so we better get started, and not lose too much of everybody's valuable time here. So welcome to Link State Vector Routing Working Group. So we didn't meet at the previous IETF meeting, but we decided to meet right now. As everybody has noticed, the working group itself, the email list has not been, the most active one. So I think you can count most of the emails of each month on a single hand, which is a little bit, unfortunate. Anyway, so here we are. So we don't really need the JavaScript because we have our texting tool within the Ecmp tool, so which is directly attached, which is very nice. For minutes, as I mentioned, it would be very appreciated if people, who actually are attending here, to to help taking minutes here. If we make this a collaborative effort, it will make it easier for for everybody and for the chairs to collect the minutes at the end, and will reduce the burden for a single person to take notes. Before we go on, let's also have be aware of the note well. By now, you should have seen it already a few times. Read it. Be aware of it. Anything you say, here at the online event will be seen as a contribution towards IETF. Be aware of that. So for the agenda, as I mentioned, we have 60 minutes today. We have 4 different topics. We're first going to be covering like a quick agenda bashing as one word, speak about some of the drafts we have in the working group itself. Then we're going to have a short update on the Bgp Spf technology and to understand the state we are in at this point in time, where the draft is. Then a new draft is going to be introduced about Bgp Spf flooding reduction, followed with the IEEE update on Lldp v2, and to understand where we are, where that technology actually is at this point in time. As I understood, it's actually almost ready for release, which is a good thing. And then at the last topic here, we're going to discuss a little bit on what are going to be the next steps, for the working group itself, once we have delivered the BGP link state short spot routing document towards the IESG. Any suggestions or comments about the planned agenda here? There should be no surprises. Okay, perfect. So if you look into where we are with our documents here, so we had 2 documents which went to working group last call. The AD reviewed them and they sent them back to the working group for updates. The Bgp Spf one has been updated based upon the feedbacks here. We are now at release 15. And those updates are going to be discussed by Keyur. There were also the other draft, the LSVR applicability, release 7 was reviewed by our area director. There was like a whole list of review comments that came out of that. The applicability draft.
Is everyone seeing the slides? I just got a note that some people may not be seeing the slides right now.
Oh.
I'm seeing them. Yeah, I'm not seeing the slides.
You're not seeing the slides.
Yeah, I can see them, but apparently some of the working group members don't see them.
Oh. That is for everybody or just a few people?
Let's ask Paul here. Put him in the queue. Oops.
Because I'm sharing them from the Meet Echo pre-shared tool.
So let's ask AC. Oh man, I think I'm rejecting you, AC. Do it one more time. I don't know why I didn't. I tried to get you to speak there. 1 second here.
I see in the chat.
Oh, they can see now. They can see them now. It looks like there's a delay. They can see them now. There's probably a delay. So please continue.
Okay. Yeah, I don't know when the slide actually started to appear for the audience here. But coming back to this slide, so I hope you're seeing slide 5 here at this point in time. So the Bgp Spf draft 13, which was released in the beginning of the year, has been further updated to release 15, where we are right now. Also, the routing area directorate reviewed the earlier versions, and the feedback of that review got into version 14, which was now updated to release 15 also, which is going to be discussed by Cure. The applicability draft, so the version 7 was reviewed by our area director. He had like a long list of updates on that one. Those updates were, I think, processed by the authors of this draft, and release 8 actually came out of that as a result. Now, I did a diff between 7 and 8, and it seems to be inconsistent with the big number of comments from our area director and the updates to the draft. So I'm not really sure, what actually, what exactly happened there, on the progressing. But I'm pretty sure, that the authors will, give an update to that one also. So the plan is, once we are finished with the Bgp Spf and the applicability, that they will be submitted at the same time towards IESG for further processing. Now, then we also have our L3dl drafts, which have been progressed. They have all been refreshed on the 14th of October, which is very good. These drafts are now a little bit in a pending state, because it would be very good, to keep working on them, but we can only progress them further after we have, fully confirmed with our rechartering to actually keep them into the, to bring them into the charter of our working group here. Mainly because there is a similar-ish, technology at IEEE, and to avoid procedural issues and problematics, it would be, very beneficial for us to have these explicitly mentioned in our charter as a working group item itself, to make things easier. So let me see where we are now. Okay, so that's the IEEE status. So any further questions before we, or comments, before we go into the first session from Keyur? Okay. So let me try to share the.
I don't see anyone in the notepad. I'm taking notes for now. Okay.
Okay. So I'm gonna go to the next section. Voila. So Keyur, is it popping up here for you, the screen?
Yes. Yes.
Okay.
And are you going to flip the slides for me?
If you cannot click the slides, if you don't have the authority to click the slides, I will click the slides for you. I don't think you have.
No, I don't.
Okay, just tell me what you want me to do.
Super. Thank you. Hi, folks. My name is Keyur Patel, and I'm going to give an update on Bgp Spf since the last working group session we've had here at IETF. Next slide, please. So the version 15 of the draft is out. I think we posted version 15 in July. In here, we have made text consistent when it comes to the usage of BGP speakers. We now call them as BGP SPF speakers as a terminology, a minor nit, but we have made it consistent across the draft. We've also provided a clarification on SPF packing update message for the NLRIs. Chances are very high that because BGP attributes are going to be very prefix specific, that the update may only carry, in a lot of cases, a single prefix. should not affect anything, considering and knowing that number of prefixes in underlay are always going to be smaller. But we've nonetheless made the clarification. It doesn't guarantee that the packing will not carry more than one update. So the text is added. We've also ensured with an appropriate text clarifying that only one status TLV is to be advertised in a given update message, knowing that the status TLV is common for link attribute, node attribute, and the prefix attribute. Also beefed up error handling section with regards to the status TLV to ensure only one of the status TLV is carried in the update message. Next slide, please. Also, in the best path algorithm selection, which is an SPF algorithm here, we have provided clarification of handling of ECMP next hops. Although this is very implementation dependent, but it always makes sense to get to a deterministic ECMP selection. So the way to get there is, first of all, the next hops should be bounded to number of ECMPs that are configured on the router. Once you've bounded number of next stops to the number of ECMPs, always a numbered link next stop is preferred over an unnumbered link next stop. And when you are looking at numbered link, highest address on the numbered link as well as highest remote identifier on the unnumbered link is always preferred. This will always ensure deterministic next stop selection that will be done for the ECMPs. Yeah. Next slide, please. We've also provided a clarification text in SPF algorithm section as well that says, how do you match a given link? What are the criterias for that? So on the numbered link, we've said that the link descriptors must have to share V4 or a V6 subnet for a link to be considered as a matching link. On an unnumbered link, the current link's local identifier must match remote node's link remote identifier, and vice versa. The current link's remote identifier must match the remote node link's local identifier. If you do that, the link is considered to be matched, and it's considered to be found as a matching link in the database. Also added error handling text for particularly IPv4 prefix length TLV, where you say that any length error in prefix length TLV, particularly for IPv4, must result in first the dropping of the TLV. Then you ensure that the corresponding node NLRI is also considered as an error, and you do not advertise it further, you drop it. Furthermore, ensuring also that a corresponding link NLRI is considered as malformed and must handle as a treat as withdraw. So the link error handling text, the prefix length TLV error handling text has been also beefed up to make sure that the appropriate error handling is done for its associated node NLRI as well as the link NLRI. And there were some minor needs that we had fixed in the draft as well. Next slide, please. Thank you. Here's the diff on the version 13. Both version 13 and version 15 came out after the implementation were pretty much done, and they have been incorporated in implementation as well. In version 13, of course, we had received AD comments that we had incorporated. We had beefed up error handling to great extent. Security section was added. We clarified the interaction and relationship to BGP-LS again and HTLVs compared to BGP SPF SAFI. Overall clarification text provided, and of course the SPF section, which is pretty much an implementation specific section, was augmented to provide very detailed description of how the best path selection should go for. Yeah, next slide, please. So after version 13 and after version 15, the overall status summary of the draft is as follows. Most of the text changes that we have incorporated so far has minimal impact on implementation. Error handling is the exception, where we had to go in and really look into implementation to make sure that appropriate error handling was in place. INA section has also been updated with the implementation based TLV values that were missing earlier. Yeah. Next slide, please. At this point, we have received reviews from numerous folks in the working group itself. Of course, we have also had a review on the routing from the routing area directorate as well. All the issues that were raised were addressed, and hopefully the status is cleared by now. We've also received a detailed list of comments from our AD, and we've addressed all of them. The working group last call at this point, from our perspective, is successfully done. It was done once, been sent again to the working group, and we've taken care of it. We request the chairs at this point that we feel draft is in a very stable state with an implementation, so that the chairs, we do request the chairs to complete the last call and progress the draft. Last but not least, we have multiple implementations on this. This one open source implementation also been made available on the FRR, in FRR itself. Next slide, please. Yep, and the last work that is in place, this is fairly straightforward, is the support for Yang models. Since only support for new SAFI is to be provided, there should be a fairly straightforward draft that we are thinking of putting it out by next IETF. And I believe that was my last slide.
You are correct.
Any questions?
Eerie silence. So basically, what you need for this to for this piece of work to progress through our working group is the IANA code points, I guess.
I believe we already have them.
Ah, okay. I thought you actually had to implement one, but I'm not sure if they were actually assigned on the first come first serve base at this point in time. Okay.
That is correct.
Yeah. Okay, cool. So we'll work on closing that working group last call thing then, and then push this thing onwards. Okay, thank you. Now let me go in. No further comments. Okay, you're welcome. Thank you, Keor. Now we have the next section. Hey Mo, you are alive. Is your audio working?
Yes, I'm here.
Okay, super. Can you see the slides?
Yes, can you hear me?
Okay. Yes, I can hear you perfectly well. Okay, thank you. Go on.
Good. Hello, everyone. Today I'm going to talk about the Bgp Spf flooding reduction. Next page. At first, I'll have an overview on existing Bgp Spf flooding procedure, and then revise the flooding procedure for flooding reduction. At last, protocol extensions to support this flooding reduction. Next page. In existing Bgp Spf flooding procedure for RR model, Bgp speaker will send its link states to every root reflectors. After receiving these link states, every root reflector will send the link states to the other Bgp speakers. For example, in this figure, node A will send its link states to both RR1 and RR2. RR2 are these two root reflectors. After receiving the link states from node A, they will send the same link states to node B and C. So in this case, node B and C receives two copies of the same link states. So one is from RR1, the other is from RR2. So one copy is redundant, maybe also to be reduced. Next page. So in existing Bgp Spf flooding procedure, in node connections mode, so whenever a Bgp Spf speaker consider its link up or down, so this will trigger the advertisement for this link states to all the nodes through all the Bgp Spf sessions in the network. For example, consider this simple topology. So when node A consider its link, for example, link from A to D is up, so node A will send this link states about this link up to all the peers through all the sessions. For example, node A will send 4 copies of the same link states to through 4 sessions. So first session from A to B, and then second session also from A to B, and then the third session is from A to C, and then the fourth session is from A to D. And then after receiving these link states, the other nodes will do the similar things, will send those link states also along the sessions. So this flooding procedure is illustrated in those kind of blue green arrows. So we can see we have lots of link state floodings. So next page. So revised flooding procedure in RR model. So in this revised procedure, Bgp speaker will only send its link states to some of root reflectors. And then after receiving these link states, so these root reflectors will send the link states to the other Bgp speakers. For example, node A will only send its link states to only one root reflectors, RR1, for example. And then RR1, after receiving the link states from node A, it will send that link state to B and C. So we can see that node B and C receives only 1 copies, and then we don't have redundant copies for the same link states. So this compared to the normal flooding procedure, and then we reduce the amount of flooding by half. So next page. So revised flooding procedure. So this is another option for revised flooding procedure for in the RR model. So in this option, so we divide all the nodes evenly into number of groups, and each group will send their link states to only one root reflectors. So for example, first group will send to their link state to the first root reflector, and then the second group will send their link state to the second root reflector, and so on. Since we evenly divide the number of nodes into number of groups, so the work node is balanced among all the root reflectors. So next page. So we're talking about revised flooding procedure in node connections mode. So in this mode, the procedure, the revised flooding procedure is similar to the one in the IGP flooding reduction. So basically, every node in the network will have a flooding topology. So this flooding topology we can obtain in two ways. In one way is that in distributed mode, every node will compute its own flooding topology using a same algorithm. So the second option is that in centralized mode, we have a leader, and then that leader will compute a flooding topology, and then leader will distribute this flooding topology to every node. So with this flooding topology, every node will send the link states to the peers, which is connected by a link on the flooding topology. Or say we just do the flooding along the flooding topologies. We will not do the flooding along the real flooding topologies. For example, on the left side, we have a flooding topology for the real network topology on the right side. So when node A consider one of its link is up or down, node A will only send the link state for this link along the flooding topologies. So node A will only send two copies of its link states. One is along the link on the flooding topology from A to B, and then the other one is from A to D. This is along the flooding topology from A to D. So this we can see. So the blue arrow illustrates the flooding along the flooding topologies. We can see that the amount of link state flooding using this revised procedure is reduced a lot compared to the normal flooding procedures we talked about in the previous slides. Next page. So this page just describes procedures or algorithms for computer flooding topology for Bgp Spf. So this algorithm is similar to the one in IGP flooding topology computation. So the only difference is that we consider some special attributes in Bgp Spf. So this difference is highlighted here. So in Bgp Spf, we have some node which do not support transit. So in this algorithm, we consider this a special case. So for the nodes which do not support transit, so we will consider that one in the leader election. So we shouldn't elect the leaders that doesn't support transit. So in addition, so when we compute flooding topologies, we will minimize the connections to the node that do not support transit. So that's the only difference compared to the one in the IGP flooding topology computation algorithm. Next page. So protocol extensions. So this protocol extension just is quite similar to the one in the IGP flooding reduction. So maybe some kind of a difference. For example, because we have different mode in Bgp Spf, so we have a special one for Bgp Spf flood reduction. So one is a node flood TLV. So this TLV contains a flood behavior field. So this field will indicate the behavior network node will take for flooding. So for example, number one indicates that network node will send the link states to the root reflector with minimum node IDs. So number two will indicate the network node will send link states to the RR with maximum node IDs and so on. So the leader root reflector will use this TLV to tell every node how to flood its link states. So next page. So this is a leader preference TLV. So this TLV contains priority field and the algorithm field. The priority field indicates that the node's priority for become a leader. So every node can use this TLV to advertise its priority to become a leader. So this TLV also contains a field for algorithm. So this algorithm is a number. So it's mean 0 means centralized computation for flooding topology. If it's non-zero, which means that its algorithm will be used by every node to compute flooding topology. So leader node will use this field to tell every node whether it's a centralized flooding topology computation or indicate the algorithm every node will be used to compute its own flooding topology. Next page. So algorithms support TLV. So this TLV contains number of algorithm numbers. So every node in the distributed mode may use this TLV to announce that I'm support number of algorithms. So next page. So node ID TLV. So this node ID TLV is used in the centralized mode. So this TLV contains a number of node IDs, first node ID, second node ID, and so on, and also contains a starting index. So this information provides a map. Node ID, first node ID has index, starting index. The second node ID has a starting index plus 1 and so on. So this is a node ID to node indexing map. So the leader node.
I think we have a question from Kayuri's in the queue right now.
Okay.
I just had a quick question. I can wait till you are done with the presentation.
Yeah, good. Thank you. Yeah, that will be better.
Okay, I will wait.
Yeah, so leader node will send this node mapping to every node in the network. Next page. So pass TLVs. So pass TLV contains index 1, index 2, index 3. So this each index is associated with a node. So this TLV encode a part of flooding topologies. In fact, it encodes a connection from node with index 1 to node with index 2, and then connection from node with index 2 to node with index 3, and so on. So next page. So connection used for flooding. So this TLV just contains local ID and remote ID, which is specify a connection. So this connection is on the flooding topology and which is really used for the flooding. So next page. So I would like to receive feedback and comments. Thank you. Any questions?
Yeah, this is Keyur Patel, Arcus. Quick question. How does this work with partial implementations? So if you have a network with 2 route reflectors in your previous slide that you had with 3 nodes, if only one route reflector implements this extension or one of the 3 nodes implement this extension, how does this still work?
Yeah, that's a good question. So we can consider the normal case, right? The load connection model. So if some of nodes in the network have these features, flooding reduction, and the rest of or some of the don't support flooding reduction. So that is okay, because on the node with flooding reduction, and then they just flood on the subset of flooding topology. So when those link states reach to the node that don't support, and then those nodes will flood or send the link state to every node connect to itself. So that will work. But for the sparse mode or root reflector mode, that one if some are support, but the other root doesn't support. In that case, it looks like we need to have more considerations.
Okay, AC, I think it's your turn.
Yeah, I opened up my audio, the AC Lindum Cisco Systems. I was just going to say that maybe what you're doing with splitting the route reflectors and having that may be enough. I mean, we already support sparser BGP Spf by virtual supports, sparser sessions, depending on how much redundancy you want. Now, what you're doing with the with selecting only one RR for groups and making sure all those cases, that may be enough rather than going the whole ball of wax and supporting many different algorithms like we're doing in the IGP centralized and distributed. I'm thinking that might be going, I can't even think to what that does to BGP, but that's just my comment. I'm thinking just focus it, have those the simple case where you just prefer one route reflector, split off, and this whole thing with the adopting the dynamic flooding algorithm framework that we have that we're doing in the IGPs and BGP SPF may not be needed. That's just my comment. Thanks.
Yeah, I agree. Yeah, I agree. For sparse mode, and then we should use a very simple procedures, right?
It's very similar, but I think it could be. It's pretty complex. I mean, I think just getting getting it implemented, and we have 2 implementations now, getting that implemented. Then if on top of that, if somebody did the extensions to support, selection of one route reflector, that would take you a long ways. I mean, you already got a pretty sparse, and you also handle the cases where connections are lost. I mean, you probably have the 2 route reflectors, of course, they need to peer with one another, and that needs to be reliable. But other than that, I think, I don't know that you need this whole framework. You want to be able to run around the block before you attempt the Boston Marathon and set this whole thing up with the dynamic. Look at how long we've been doing things in IGPs, right? I think you might want to split the 2 out, just because of that. Anyway.
Okay, thank you. I consider that one. Thank you.
Yeah, and me, speaking as a participant here, so I'm not sure also that the flooding dynamics of this BGP SPF is similar enough to what we are seeing in the IGP, yeah, because in the IGP world, we're not really relying upon reliable sessions here to send the updates over, while we do have that in the BGP world, which means, I think in IGP there is probably like a higher risks of multiplying the flooding dangers here, which are not happening in this case, I suspect.
Yeah, the BGP is a reliable connection, but the amount of link state sent over the session, so that one is similar to the IGP, right? Even so, the link is reliable, so we still will send link states to all the connections. So the only difference is that BGP will do the retransmit, or something like that, or reflooding every hour or something like that. So that one, those kind of reflooding is limited in the Bgp Spf, but the amount of link states sent out from all the link sessions is still there.
AC? AC, you're in the queue. Is that on purpose or by accident? Think your mute is on or something like that.
Before he was talking.
From the queue when after I spoke.
Okay. Any more questions? Because we do have to go to the next presenter here. So
Thank you, everyone.
thank you, Huemo.
Good. I'm wondering if I should share my screen. There's some minor, very minor animations that might be helpful for understanding.
Sure, if you want to take that risk, you're more than happy to do so.
Let's see if it works. So I did this request, but I don't know how.
Okay, I think I have to click grant screen.
Yes. Okay. Okay. I think maybe it's working. Yeah, we got the infinite screen.
Yes.
Okay. Okay. So is that is that displaying
It's coming
properly?
through. Yes. Perfect.
Okay.
Yes.
All right. Thanks. I'll go ahead and jump in and try to move quickly for discussion. So this is an update again. We've done a few in the past, which I'll talk about. Just as a start out, as a disclaimer here, since I'm talking about an IEEE standards activity, I need to point out that this is my own personal view of that. I've been obviously participating in that, but and I think my view is accurate, but it is my view, not the position of the standards board here. So obligatory slide. So first of all, we were motivated by the requirements of L3dl and other use cases, I think like IDR and some others, that there was a need to update Lldp to allow the sharing of more than one frame's worth of information. So I'm referencing some previous presentations where we went through that requirements discussion. And frankly, it was time to do an update to Lldp. And we know that LSVR had evaluated Lldp as a potential transport for sharing bootstrapping information, and it wasn't sufficient. And this was one of the key issues. So anyway, we proposed to fix that, if you will. And we started a project in 802.1 called 802.1 ABDH that was intended to allow support multi-frame protocol data units in Lldp. So I have a link here to the project page if you can track all the history and things that have happened. So from a timeline perspective, the way it works in 802.1 versus IETF, we go through a number of different balloting phases. The first step is to get a project authorized and requested, and that actually happened back in September of 2019. And so not a lot happened until really almost a year, because we were looking for an editor and kind of dragging our feet or whatnot. That technically we thought we knew what we were doing, but we finally secured an editor with some help from some other people. He's an excellent editor, Steve Haddock, who I've listed on the slide deck here. Anyway, we entered the phases of balloting, and the first phase is task group balloting, which is where it's kind of open, focused group of people. We did two rounds of task group balloting before we went to what we call working group balloting, and this is where it's mandatory for working group members to pay attention and vote. We did 3 rounds of that, and then we went to what we call standards association ballot, which is kind of the final phase. Where it's open to pretty much anybody in the IEEE that's a standards association member. And we did 2 rounds of standard association balloting. So any technical changes are typically completed during the working group, task group, and working group phases. We're now at this RevCom approval, which is where we're basically the document is done. We're just proving it through the process and going for publication. I'm not exactly sure the date of publication expectation, but I do believe it's before the end of the year. So anyway, the draft could be used today. There won't be any substantive changes. So why were we doing this? Again, the main objective was to support sending more information than can fit in a single frame. So LLDP was a very simple protocol that only shared one frame at a time. But now we've sort of optimized for sharing something along the order of, let's say, 100 kbytes. When we first did this, it was believed in LSVR that something along the order of 60 kbytes was needed. I'm not sure what the upper limit is now, but it's probably bigger than 100K as well, but we could actually do the math. And we wanted to also allow the ability to shrink LLDP frame sizes too for certain deployments. There's a lot of effort in time-sensitive networking where timing is very important, and so sending smaller frames was a useful outcome of this as well. One big objective we had was we wanted this to still be able to communicate with old LLDP implementations. Obviously, only one frame's worth of information, but it's designed to talk to old implementations as well. And if you support the extensions, then you can send more information. We want to make sure what we're sending is valid. We allow the mechanism allows what we call pacing of receiving of those frames by the receiver. So in other words, if you have a very lightweight implementation, we're not going to overload you. You receive the extra data at your own speed, so to speak. And that's important. There's a lot of very constrained implementations of LLDP. And then we didn't want to add any additional, network traffic. So it's a periodic protocol. LLDP is in general, but when we add a bunch of extra frames, we don't want to be uselessly broadcasting those around. So the protocol doesn't add any really additional network traffic in its design. So just as a quick reminder, this is how original LLDP works. You think of it as each agent has a database, is what we call his local database of information that he wants to share to his neighbor. And the neighbor maintains what's a remote database, which is just a copy of that. And so then basically it's a simple protocol, right? Periodically a timer goes off and you just send your database to your neighbor. And again, remember, it was one frame. And then that neighbor would receive it and effectively replace everything that was there before with what you just received. So things get wiped out. It's and then the sender would do the same whenever anything he changes, or if a timer goes off that he hasn't updated his information lately, then he just sends a frame. And of course, if you change something locally in your database, then we try to send that frame immediately with some kind of rate limiting kind of thing so that we don't overload implementations, but you can get your information propagated relatively quickly. So that's LLDP version 1, the simple one, very widely deployed, lots and lots of use cases. And so what we did to allow additional frames to be added was created, an extension protocol, if you will, that has what we call receiver pacing. So in this scenario, let's assume, something changes on this left agent's local MIB. He sends out a single LLDP frame, a new, it's the same LLDP frame as it was before, but it contains a new TLV that's called a manifest TLV. And that manifest TLV describes that there's more information available to be retrieved. And so what happens is the receiving agent then now sends back a extension request frame saying, I want the rest of your data, specifying specifically what data he wants. And then the sender will send an extension PDU, which is looks like an LLDP frame, but it's got a special format. And so then the receiver will collect that information until he gets it all. As soon as he gets it all, then he updates the local MIB. So from above API level, if you will, it looks exactly the same. applications that run on LLDP look exactly the same. They just have more data they can send and receive than they used to. But below we have this extra protocol. And then there's still a periodic thing that happens, every so often, that you'll still send your one LLDP frame. And if nothing's changed in your extension database, then nothing happens. It just, on the other side, he just refreshes that basic information. So it's pretty simple protocol extension that we did. So in doing it, what we had to do was define 3 new TLVs and 2 new PDUs, or LLD PDUs. So, and there's details in the backup I won't go into, but there's a manifest TLV, which is this new one that describes all of the other extension PDUs that are available. So you send out this manifest saying, I have, 10 more LLDP frames, and here's what they look like. Here's their numbering system, whatever. And then when you send a request for one of those PDUs, you include this extension request TLV. And then when you're sending your extension PDU, you add the extension PDU TLV to the frame. So there's 3 new TLVs, and then these are the PDUs. There's already the quote normal PDU, so that one remains the same. It looks the same. However, if you add this manifest TLV, then you're now saying I have more data. Because this manifest TLV wasn't defined in the first version, implementations, backward compatible implementations would simply ignore it. That's how the protocol was specified. They would store it perhaps as an opaque data, but they would ignore it. And then these new PDUs are extension request and the actual extension PDU itself. We use unicast addressing here, or we specify the actual address. So you flip from a multicast protocol to a unicast when you're doing the extensions. That avoids a lot of confusion and flooding in the network. And then you have specifications in here of exactly how to identify the PDUs. So as I mentioned, there's details in the back. I won't go through that. So what are the next steps? We're just waiting on that publication. Effectively, like I said, it's a logistic thing, no technical details. There was a draft I wrote with Paul Bottorff a long time ago that was identifying the current set of L3dl TLVs. And we were proposing, well, we format them in the LLDP format. That didn't get a lot of other joiner interest, so to speak, at the time. But maybe it would be worth considering dusting that off and looking at how to share the information that's currently being exchanged or needs to be exchanged. And then of course we're looking for someone to update the LLDP agent in open source world to support this new activity. I'm not aware of anybody yet doing that, but that'd be a great project. If somebody was interested in doing that. So that's the end of the update.
So
questions?
Paul,
Yeah.
Yes, here, Gunther. As a chair, so also before you mentioned like security and so onwards, because like in data centers, the application realm of LSVR, security is a high important thing. So security was mentioned, in some of the previous, updates, but it was not in this particular update. Is there like, so what is the status, from that perspective for LLDP?
Right. So early on, we had considered, should we be adding some kind of additional TLV to frames that would, either put an HMAC or something to protect, identify any kind of changes or something, but not necessarily privacy protection. We just decided to not do that at this time for various reasons and complexities with security. I think the security that's typically used, in 802.1 is to try to protect the link itself by using something like MACsec that would operate below this and allow these frames to be both privacy and, integrity protected. So that's the sort of the default answer, is that we would use the 802.1 security framework to protect this rather than instrumenting a specific security attribute to this. But that could, of course, be an approach that could be considered in the future if we wanted to augment that. But we didn't address it directly in this protocol.
Okay, thank you. Any other questions from the people in the room? No? Okay. Thank you, Paul.
Great.
Thanks for the update. Very interesting. Very good progress. Appreciate it.
Yeah. See how I stop there. Okay.
There's no escape.
We have 5 minutes.
So we have 5 minutes left. So I think the last topic on the agenda was to look at a potential recharter of the working group itself. Victor, do you want to say something about it, or should I keep on going?
This is it. Speaking ball.
Okay. So basically, I think we already mentioned this in the beginning of the working group meeting here. So now that we are going towards the end of our initial tasks of the working group, of the L3dl working group with the protocol spec itself, we need to look into how to progress, and maintain the technology, and also on how to further enhance the realm of what we are doing and the accompanying technologies. Because the Bgp Spf by itself, even though it's a very good and fine technology, it seems to need some supplement technologies like L3dl or Lldp v2 to discover the neighbors itself, because unlike a traditional IGP, the technology has been separated between each other. So from that perspective, we need to augment our charter, because that was not part of the initial charter itself. And now that we have more visibility, that is a track we're going to take. So what you will see happening is, from the moment that Bgp Spf and the applicability has been pushed upwards, that we will be starting to discuss a recharter draft text on the working group itself. We have some texts initially pre-drafted already, but we're going to be sharing that very soon after Bgp actually has been sent up.
Yeah, now Gunter, I guess what the plan we'll have is we'll put that on the list. And did we have an idea of what timelines? Like, I mean, we probably don't want this to take forever. How much time do you think we should put towards getting comments in and allowing for reasonable amount of input and discussion?
No, I don't. No, I personally don't know how long normally a recharter kind of takes, but I would hope that at IETF 113 we're gonna have something written down and approved, hopefully.
Yeah, I mean that's we definitely would want to be, if we're going to have that recharter completed, it should be before 113. Okay, I think that's the timeline that we work backwards from.
Okay, any questions or concerns from the working group on this?
Let's see if we get Kier to talk.
Kier?
Just a quick question.
Are you in the queue in by accident or on purpose?
Can you hear me?
Yes.
Yes.
Yeah, this is Keyur Patel. Arcus, just a quick question. So are we looking to recharter by 113 is what I heard?
That is the intent.
Okay. And as part of rechartering, we want to include the discovery part.
Yes, correct. So the intent will not be that that the charter will mandate like either L3dl or Lldp v2, but more to include the work upon the discovery technology. Correct.
Yep. And this is going to be, the rechartering is going to be very specific to discovering technologies in data centers.
It's basically the framework or the baseline to bring the L3dl work into the working group. Correct.
I understand, but my question is more specific to the text of rechartering. Since LSVR is defined for data center extensions. I am assuming the rechartering in context of discovery will be also for data centers? Or is that going to be on a wider scale?
I think that is something we can discuss, on the working group list itself. But my as a chair, we are working upon LSVR, which is technology, tailored for data centers. So I think that is going to be our initial focus, of course.
Super. Thank you.
Probably have room for only one more quick one, and then we have to probably get going. Randy, you.
Just so you know that L3dl is among the technologies being discussed in IDR, which for BGP peer discovery, and this segment of the IDR work is focused on data center. So I understand Kayr's concern for understanding the focus here, and enough said.
Thank you, Randy.
I'm just going to point out that that recharter has to go through the IESG, so we might have it ready to go by 13, and then do the final, and then push it after that. You have it has an approval process just like a document, the recharter.
Agreed. And so
Depends upon how many more years we sit on our thumbs, doesn't it?
That's true. Okay, so Gunter, let's do this. Let's put this to the list. Obviously, we can finish up this conversation there. I think there needs to be some clarity in terms of what we're focusing on. I think Kayr was reasonably correct in that original charter was we were focusing on data center protocol operation, and this discovery would have been in context with that, irrespective of maybe wider potential applicability. Is that fair?
I think so.
Yeah. Okay. So we'll have to take this to the list, as I think we're 2 minutes over now.
Yes, I think we're at the end of the meeting, so I think we have to close it down. Otherwise, we're going to get kicked out. Okay. Thanks, everybody. Bye-bye.
Thank you. Bye.